14. It says the County Fair Ferris wheel. Consider the picture of the Ferris wheel. The wheel has a 60-foot diameter and is drawn on a set of axes with the Ferris wheel's hub at the origin. Use a table like the one below to draw a graph that relates the angle and standard position of the spoke leading to your seat to the approximate height of your seat above or below the height of the central hub. The table below starts at -90, your starting position before you ride around the wheel. And then we've got this nice little table. So if you remember when we learned sine, cosine, and tangent, especially sine and cosine, it introduced the screamer ride, and we learned that sine, it would model how high above, like if this was the ground level, and I made a little triangle, this height right there, we found out that that was sine, because this is a right triangle, and sine is opposite over hypotenuse. But in a unit circle, hypotenuse is 1, because it's a unit circle. So we're just this problem is, I guess, trying to relate that to you. So let's go ahead and see if we can fill out the table. So it wants us to fill in the table. We're trying to find the height. Okay, so they already started at -90 degrees. So -90 means you're opening an angle down this way in a clockwise direction instead of the counterclockwise from the x-axis. So if I go clockwise by 90 degrees, because this is the right triangle, that's 90 degrees, then what's my height going to be? Well, they already told me that the diameter is 60, so the radius has got to be 30. So I already know that this position right here is 0, -30. Or in other words, if my seat was right here, I'd have to climb up 30 feet to get to ground level, or the level of this axis. So 45. Oh, -45. Okay, so -45 is this right here. So I can draw a triangle, and then I can find out that sine is opposite over hypotenuse, isn't it? Let's see. Yeah, the SOHCAHTOA. So it's going to be this over the hypotenuse, but what is the hypotenuse? We know the radius is 30, so this is 30. So I can say sine of well, let's just do 45. Sine of 45 equals opposite over hypotenuse. That's x over 30. So basically, I can multiply both sides by 30, and I'll have 30 times sine of 45. That's going to be x, which is my height. So I'm just going to do it on my calculator. 30 times sine of 45 is 15√2. I could have used special triangles for all of these, or I could have used a unit circle for all of these. That would be nice. I noticed that your answer book is showing it in decimals, so I'm going to show it in a decimal. It's 21.2, but it's down, so I'm going to say it's -21.2. And then 0, well, if the angle is 0, my height's going to be 0. If the angle is 45, don't I already know what this is going to be? Because there's a symmetry here. It's going to be, you can do it on your calculator if you want to. This is 30, this is x, and this is 45. And you can do your SOHCAHTOA if you want to, but you're going to get that same number. It's just going to be positive. Okay, 90 degrees, we can figure that out easily. My height's going to be 30. 135, well, guess what? It's the same darn triangle. It's got an x and it's got a 30, and this is a 45, 45, 90 triangle. So it's just going to be another version of this 21.2 number. And these are all feet, by the way. Okay, 180, what's my height going to be? Well, it'll just be 0 right there. 225, well, it's not a very straight circle. This is a 45, 45, 90. It's just going to be another one of these. It's going to be negative 21.2 because we don't need to keep calculating this over and over again. 270, my height's going to be, well, it'll be negative 30 again. So I filled this out, and then I'm supposed to get myself a graph. So I know that the highest and the lowest I'll ever go is 30 and negative 30. So I just put those on the y-axis, and then I just put the angle measures that I have points for on the x-axis. And I spaced them evenly because this is chunked into even increments here. Okay, so at 0, where's my 0? I got 0, 0. And then at 45 degrees, it's 21.2. So if I went like 10, that's 10, 20, if that's 10, 20. So you just have to fake it. It's 21.2. 90, I'm going to go all the way up here. Right? 135, well, let me down here. 180, 0. 225, negative 10, negative 20. So where are we? Right here. 270, where's 270? It's going to be negative 30. And I know if I make it keep going around and around, it'll eventually go back where it started from. So it should look like a sine curve. And so I could do the same thing. I kind of like to cheat. Here's my shortcut. Since I know it's going to pass through these little halfway marks, like the ones that came from the 45, 45, 90, I kind of cheat and just use the 90 and the 180 and the 270 and the 360. And then I can just get that it's going this. So it's like I kind of didn't bother plotting those 21.2s, but I made the graph go. It's not beautiful. And then, so the wheel goes around counterclockwise several times during a ride. How can you reflect the fact on your graph and update your graph? I already kind of automatically updated it because I made it, like I can make it go, I can make it keep going and going forever and ever. Hey, oh, I'll just put arrows. That updates my graph. And then, what is the maximum distance above or below the hub? Well, we said it was going to be 30 because that's the radius. Write an equation. So an equation would be y equals, didn't I have to keep going 30 times sine of 45? And like if you put that in your calculator, 30 sine 45, you're going to get your angle measure. If you put in 30 sine 90, you'll find out. You should try some of these values in here. It's going to be 30 times sine of x. And I can plug in whatever I want. Like in this case, I plugged in 45. That's where I got the 21.2. So this is, and so 30 is the amplitude, sine x. And we know it's a sine graph because it looks like our parent function. And that's it.